Hi everyone, it's Stephen Downs here again with another episode in Ethics Analytics and the Duty of Care. And we're into Module 7 on the decisions we make. And this presentation is called How AI Works. Now, we're not going to explain how AI works in this presentation. So let me be clear about that right off the bat. But by the same token, it's important for the purpose of our subject to have a sense of what's going on in a typical artificial intelligence or analytics application. Because a lot of the discussion gets really hand-wavy. And what I like about artificial intelligence, especially when it comes to talking about, and neural networks, especially when it comes to talking about cognitive phenomena, learning, training, development, and all of that, is that we can actually describe the process. We can describe it mathematically, we can describe it physically, we can even describe it sociologically. In terms of, say, messages or communications between entities. Now, people might say, well, yeah, you're just being reductivist or you're displaying your quantitative bias, and my reaction is, well, whatever. If you have an alternative theory of how these things work, tell me what it is. But in such a way that I could make one or reproduce it or use it to actually make predictions or any of the other things that we expect the science to do. Now, I've been kind of pulling my hair out today getting this ready, and I actually ran one of the videos in the discussion session. I want to say there are many good introductory videos out there for this subject. And I want to say these are better than mine. This one here is the one, the top one is the one that we showed during the discussion today. So I'm not sure if YouTube allows me to run a video containing another video. We'll find out, I suppose. This is another, the last one here is another really good in-depth discussion of how a neural network works. So if you're really serious about it, watch these other videos and maybe follow up in more detail. The purpose of this particular video is a bit different. I want to talk about how it works, but I want to do so in a way that is focused on understanding the concepts, understanding the terminology, and especially getting a sense of the sorts of decisions and the sorts of decision points that will come up in the development of artificial intelligence and analytics software. It's not going to cover everything by any means. This is super introductory, and even then, there's no doubt that some of the people who actually know what they're doing in the field will complain about this presentation. Still, let's go with it. And I'll put it up for correction, and we'll be corrected later if we're wrong. But I think most of this is pretty solid. I feel good enough about it that I'm actually committing it to video, so that should say something, because nobody wants to look bad, right? Okay, what does artificial intelligence do? And by implication, what do analytics engines or even learning analytics do? Well, ultimately, they're nothing more than a statistical function. But what makes them different is they're big, whacking statistical functions. A simple system that takes an image of a number and determines what number it is can have 50,000 different input variables. And designing an AI function is basically a mechanism of tweaking these variables. And some of the tweaking we do manually, and some of the tweaking we do using algorithms like back propagation, which I'll talk about. But ultimately, these functions are statistical associations between large numbers of individual data points. That's why they sometimes call it big data. We're not depending like we might in ordinary human calculations of things on 3 or 4 different kinds of pieces of data. We're depending on tens of thousands, or in some cases millions of pieces of data. That's really important to understanding what's going on in AI, because at core, the concepts are pretty simple. It's when you scale them and you start messing around with the structures that you get these big results. So, I like to talk about what AI does, keeping in mind it's a statistical sort of thing, in terms of 4 major categories. Again, this is just me interpreting what AI does. Regression, or in other words, finding lines or patterns in data. Feature detection, that's identifying bits of things. We'll look at an example of that in this presentation. Clustering, now I don't talk too much about clustering. In fact, I only briefly refer to it on one slide, but that's organizing data into categories. And then finally, prediction, which is, as the word suggests, making a prediction. What will happen next time? Put new data into the system, what will come out the other end? So the core of today's artificial intelligence engines is something called the perceptron, or the artificial neuron. Now I want to be careful here, because this is one of the key points where people actually get confused about AI and software generally, because you always hear people say things like, artificial intelligence can only do what you programmed it to do, or artificial intelligence depends on the rules that you set for it, things like that. Now, there was an old type of artificial intelligence called expert systems, which are based on series of rules, and then you would apply the rules to data or to situations or whatever, medical symptoms, and out would pop the answer based on the rules. For various reasons, which I won't get into, that failed. And virtually all artificial intelligence today is done using a mechanism of artificial neural networks. So, as you can guess, the artificial neuron is modeled on the human neuron. So I've got them side by side here. And again, this is from one of these videos. All of these images are from the videos, because why not? So you can see the comparison. On the right-hand side, I have a neuron. And on the neuron, we have some input, axons is what they're called. Then the neuron itself, and then some output, more axons, right? And they're connected to other neurons. Similarly, in an artificial neuron called a perceptron, we have some inputs labeled here, A, B, and C. It's the last time we'll see this labeling, but we'll leave that aside. Then the neuron itself, which is called processing, which is a bit inaccurate. And then the output, the signal that it sends to one or more other neurons. So that's the basic idea. So let's look at this concept of a perceptron in more detail. And now we'll introduce the terminology that we'll be using for the rest of this presentation. So we have a set of one or more input values. We'll call these X. So we have X1, X2, X3, and so on. In a simple example, X can either be 0 or 1. But as we can see later on, X could be anything between 0 or 1. So 0.5, 0.634, whatever. Then the output of the neuron, and we'll sometimes talk about that as the value of the neuron, or the activation value of the neuron, is Y. And Y is related to, that's what this tilde means here, related to or proportional to the sum, that's what the sigmoid does, of all of the x's. So if you have I, in this case I is 3, you have the sum of 3 x's. Okay? So basically, get your input, put them together somehow, that's how you get your output. Pretty simple. So the very simplest neuron, right, take x value, give us values for x, y, and z, right? So 2, 3, and 5. So, and then y could just be adding them up. That's 10. That's the output. Of course, that's not very helpful, and let's modify this now to make this do some work for us. So what we're going to do is, instead of just adding up the input and passing it on as output, what we'll do is we'll say that y, that's the output value, remember, has to be either a 0 or a 1. Right? So remember, the input is either 0 or a 1, and now the output has to be a 0 or a 1. So how are we going to do that? Well, what we're going to do is we'll define a threshold value, so that if the sum of the inputs is greater or equal to that threshold, the output will be 1. Alternatively, if the sum of the inputs is less than the threshold, y will be 0. So remember, before the sum was 10. 2, 3, and 5 added up to 10. So if I set my threshold to -5, then, or to 5, then 10 is greater than 5, I'd get a 1. But if I set my threshold to 20, then my input, which is 10, is lower than my threshold, so I'll send out a 0. So you see what's happening right now. The threshold really determines whether the input is enough for me to send some output. Okay, that's pretty simple. All right, but let's express the threshold slightly differently. We'll express it as what we call a bias. And a bias is a negative number that we will add to the sum of the input values. So let's make my bias 5. Okay, well, it's got to be a negative number. So let's make my bias -5. So my input is 10, just like before. Now I will add -5. So that's like subtracting 5. So my result is 5, and it fires. If it's less, so suppose my bias is my bias is -20, then it will come out as 0. So far, so good. Okay. There's nothing here, but that really should be a 0 or something. Okay. So we have now the concepts of the input values, we have the bias, and then the idea of whether the neuron will output a 1 or a 0. So we call that number, the 1 or the 0, the activation value.